All right, guys, last lesson we talked about sequences and series. Today's a special type called arithmetic sequences and series. It looks like arithmetic, but it's pronounced arithmetic as an adjective. So there you go. And I'll try to keep this short as we can, but we'll see what happens. All right, in an arithmetic sequence, the difference of consecutive terms is constant, so they differ by the same. The common difference, the constant difference is called the common difference, and it's known by D. Imagine that, the difference, D difference. Okay, so the first problem's here, tell whether it's arithmetic or not. As you can see, these are all these terms increasing by 5. So because the differences are the same, that is arithmetic. That's a yes. The second one, that goes up by 2, then 4, then 6, and that's a no because the differences have to be the same. It has to be a common difference for it to be arithmetic. All right, rule for arithmetic. This is how arithmetic works. I'm going to show you why this works in class tomorrow. But that right there is our formula or our rule for arithmetic. The way you find any term you want to. The nth term, you take the first term. If you're looking for the, well, I'll show you an example in a second. You do the n minus 1 times d. D stands for difference. N is what term you're looking for, like you're looking for the 20th term or whatever. Let me show you an example real quick. The nth term arithmetic sequence with the first term of 2 and a combination of 3 is given by this formula. Okay, so a1 is the first term, is 2. N minus 1 is there. Difference is 3. Boom. Okay, so that's how it looks when it's written out. Now, if you were to look for like a term, I think that's the next slide. Hang on just one second. Yes, this one says write a rule for the nth term of the sequence, then find the 15th term. When you see a sub 15, that means the 15th term. So let's see what we got here. The first one is going 8, 4, 9, 14. So I'm going to do an equals the first term plus n minus 1 times d. And guys, d is 5 because it's increasing by 5. I'm going to work that out just a little bit. Distribute the 5, make it 5n minus 5. Add the 4 and negative 5 together, and I get 5n minus 1. Then it says find the 15th term. Okay, so the 15th term, we're just going to plug in 15 for n, is all I'm going to do. Everybody knows 5 times 15 is 75, minus 1, 74. So 74 would be the 15th term of that sequence that we started with. Part B, same kind of deal. The first term is 60. N minus 1 times d. Now, these are a little different this time. Since it's going down, d is negative. It's negative 8. All right, so I'm going to distribute the negative 8 first, make it negative 8n plus 8. Add the 60 and the 8 together and get 68. Now, to find the 15th term, do the same thing. A15 is negative 8 times 15 plus 68. Oh my gosh, I didn't bring my calculator with me. Negative 8 times 15, everybody knows that's negative 120. Plus positive 68 is like negative 52. Hope that's good. Okay, turn the page. All right. One term of the arithmetic sequence is the 19th term right there. The 19th term is 48. The common difference is 3. Write a rule for the nth term. So the part A here, I'm going to go, okay, the 19th term is 48, difference is 3. I don't know what the first term is. N minus 1, I do know what d is. So here's what I know. Because the 19th term is 48, if I put 48 over here, I can put 19 in for n to figure out what the first term is. So I can put 19 in. 19 minus 1 is 18. That 18 is there because of that 19 minus 1. So if everybody knows if you do 18 times 3, you get 54. If you move the 54 over, it's negative 6. That's the first term. The first term is negative 6. So my rule is going to be negative 6, which is the first term, plus n minus 1 times d, which is 3. All right, and then I'm going to do what I've been doing. I'm going to distribute the 3, add the negative 3 and the 6. And the cool thing about arithmetic is there's the rule. And what it is, that's slope-intercept form. So it's going to cross the axis at negative 9. The slope is 3, so rise 3, 1 run from there. Connect the dots, la la la. And there's the graph. Okay, so when it's arithmetic, the graph is going to be a line. All right, 3 cases here. This will be the longest slide of the day. If we get through this, we got it made. Okay, the first one says write a rule for the arithmetic sequence, then find the 20th term. Okay, so the first one's what we've been doing. The rule would be the first term plus n minus 1 times d. D is negative 3 because the sequence is going down by 3. So I'm going to say, that was a mistake right there. Sorry about that. I'm going to distribute the negative 3. Just like that. Add the 17 and the 3 and get 20. Okay, now, and then it says find the 20th term. So the 20th term would just plug in the 20s. All you have to do to find the 20th term. That's going to be negative 40 when you work all that out. So the 20th term, negative 40. Let me change colors. We'll do the second one. This one says the 11th term is negative 57, and difference is negative 7. So I'm going to put negative 57 over here. This is the 11th term. I don't know the first term. I do know what n is, though. N is 11 because this is A11. So n minus 1 is 10 times the difference, which is negative 7. Everybody knows 10 times negative 7 is negative 70. Move that negative 70 over, and you would get positive 13. That's the first term. So my rule is going to be the first term plus n minus 1 times d. D is negative 7. So I'm going to distribute the negative 7 like I've done the whole entire video. Make it negative 7n plus 7. Combine the 13 and the 7, and you get 20. So there's our rule. Then it says find the 20th term. The 20th term would be negative 7 times 20 plus 20. And negative 7 times 20 is negative 140, plus 20 would be negative 120. And there's the 20th term, and there is the rule. So there's the two answers on the first one. There was a 20, there was the rule, and there was a 20th term. All right, the wildest one is number 4 here. Let's check it out, see if we can get this. Number 4, it says the first term, sorry, the 7th term is 26, and the 16th term is 71. This is going to look weird here when I do this, so hang with me here. If the 7th term is 26, that means I know this. 26 is the first term, which I don't know, plus n minus 1, n is 7, so 7 minus 1 is 6, times d. I don't know d either. I'm going to do the same thing for this one. 71, which is the 16th term, is the first term plus n minus 1. This time n is 16. 16 minus 1 is 15 times d. And what I have right here is I have a system. I need to find my first term and my d. So what I'm going to do is I'm going to subtract the second equation from the first one. So I would get this. I would get negative 45. The a1's cancel. And I would get negative 9d, which means d is 5. That's the common difference. Okay, now if I plug that back in up here, if I plug 5 in there, I'll get 26 equals the first term plus 6 times 5, which is 30. If I move the 30 over, my first term is negative 4. Now with that information and that information, I can write my rule. So I'm going to have an is the first term plus n minus 1 times d. d is 5. All right, so I'm going to distribute the 5, which is 5n minus 5. I'm going to add the negative 4 and the 5 together, which is negative 9. There's my rule. Now, I did say find the 20th term, so I guess I should do that too. The 20th term is just going to be 5 times 20 minus 9. 5 times 20 is 100, minus 9, 91. So there's both my answers. Okay, that's the toughest thing we're doing all day long. All right, the way we're going to find the sum, it says the sum of the first n terms of the arithmetic series is that formula. And I can't wait to explain to you tomorrow in class exactly where this comes from. But make sure you get that down. That's how we're going to add. Now, here's what this stuff stands for. The SN stands for the sum of however many numbers equals how many numbers there are. I like to write it like this better. Number of numbers divided by 2. And then inside my parentheses, the first term plus the last term. That's what that means, first term plus the last term. So I'm going to use this a lot tomorrow. Same thing as that. I just like to put the 2 outside with the n instead of the 2 inside the parentheses. That's just me. Okay, and I'll explain to you why I like that tomorrow. Okay, find the sum of the arithmetic series. Here we go. Here's our formula one more time. It is n over 2 times the first term plus the last term. So, first of all, n is how many numbers there are. Since I'm starting at 1 and going to 12, there are 12 numbers. So, sum of the first 12 is 12 over 2. The first term, the way you get your first term is you plug the bottom number in for the I this time. So, it'd give me 2 plus 7 times 1, which is 9. And remember, this stands for the last term. The way you get your last term is you take the 12, plug it in there, which would be 2 plus 7 times 12. Everybody knows 7 times 12 is 84, plus 2 is 86. So, I wish I had my calculator right now. That's 6 on the outside. That's 95 on the inside. 6 times 100 would be 600, so it's 5 less than that. So 30 less than that would be like 570. Okay, so what we just did, whether you realize this or not, we just added 12 terms together without a calculator in 30 seconds. Pretty quick using that formula. Okay, hope that wasn't too bad. Arithmetic sequences, make sure you have those 2 rules or formulas down. Makes the problems not too bad. We'll work on it in class like we always do. Can't wait to see you then. See you, bye.